Hi there, welcome back to another video with the Math Doc. We're still working on equations with absolute values, and in this video we will focus on absolute value equations where there's more than one term with an absolute value, which makes things just a little bit more complicated. So if you haven't seen the previous videos on absolute values and absolute values in equations, please check them out. I will list them below. And if this video is helpful, please like and comment, and let's get going. So what do we mean when we talk about absolute value equations with two absolute value terms? Let's go straight into an example that'll illustrate what we mean. So let's look at this example here. 3x minus 2 or plus 2 in absolute value equals the absolute value of x minus 8. So you see there's an equation here. We have the equality. On the right hand side we have an absolute value, and on the left hand side we have an absolute value. And so we have an equation with two absolute value terms. What do we do about this? Now, if you recall from the previous videos, what we like to do with equations with absolute values is we look at different cases where the content of the absolute value, what's inside the brackets, can be either positive or negative. And in this case, we will do the same thing, but we have to look at both of these. Now, the interesting thing here is that although we have two absolute value terms, we only have two cases here as well. What could be happening? Well, on the one hand, we might have that what's inside here, let's call this A. Okay, we have absolute value of A here and absolute value of B here. So we could have a situation where A equals B, right? In that case, obviously, the absolute value of A equals the absolute value of B. But now let's also look at the case where we don't have A equals B, but we have A equals negative B. In this case, the absolute value of A equals the absolute value of negative B, which is equal to the absolute value of B. So this too, both these cases work for this type of equation. And there aren't actually other cases. We can say that B equals negative A, but that's the same as A equals negative B. We can say that negative A equals negative B, right? But if that's the case, we can multiply both sides by -1 and get A equals B. So really, these are the two cases we have for an equation like this. So going back to our example now, we have 3x plus 2 absolute value equals x minus 8 absolute value. And we can look at the two cases, and this should cover all possible solutions. So we can have 3x plus 2 equals x minus 8, right? This is the case A equals B. Or we can have the case 3x plus 2 equals minus or negative x minus 8. This is the case A equals negative B. So these are the two cases that we solve. We solve both of them to find all the possible solutions for this equation. So let's start here on the left. We'll use our usual tricks for solving linear equations. Let's use the addition or the subtraction property. We'll subtract x from both sides. So on the left we have 3x's minus 1x, so we're left with 2x's plus 2 equals, these two x's now cancel, so it equals -8. Let's also use the subtraction property on our 2, so we'll subtract 2 from both sides, and we get 2x equals -10. Finally, what we can do is we can use our division property here and divide both sides by 2, in which case we just get x, because we had 2x divided by 2, so that's just 1x, equals -10 divide by 2, which is just -5. So that is one solution, and we will check it in just a moment. Our next solution, our next equation is 3x plus 2 equals -x minus 8. So let's simplify this. 3x plus 2 equals, we'll open our parentheses with a distributive property, so it equals minus x, or negative x, and we have two negatives in front of the 8, so that turns into a positive 8. So we have negative 8, which is positive 8. Now, again, we'll use the addition here. We'll add x to both sides. We're trying to isolate our variable. So we get on the left, we have 3x plus 1x, so we have 4 x's, plus 2 equals, these two x's cancel, equals 8. Let's subtract 2 from both sides now. We get 4x, so on the left we only have our variable term now, equals 8 minus 2, that's just 6. And let's finally divide by 4, so that we isolate our variable completely. So we have x equals 6/4. 6/4 is, I'll write this out as 4 plus 2 over 4. So that equals 1 2/4, or 1 1/2. So x equals 1 1/2. Okay, we should check our results. Check. Okay, so first for x equals -5, the way we check is by substituting in our original equation. So we have the absolute value of 3 times -5 plus 2 should equal the absolute value of -5 minus 8. Okay. Now here on the left we have 3 times -5, that's -15. We add 2 to that, we have -13, right? So absolute value of -13 equals, and on this side we have -5 minus 8, so again -13. So this is correct. Very good. Let's look at our other side. Here we have x equals 1 1/2. Again, we will substitute in our original equation. So we have 3 times 1 1/2. We'll write that out as 3/2 here. Absolute value of that plus 2 equals, question mark, the absolute value of 3/2 minus 8. Okay. So on halves, right, 3 times 3 is 9, plus 2 equals, question mark, 3/2 minus 8. I'm going to write 8 as 16/2, so we can easily do the subtraction. And we'll write our 2 here as 4/2, right? This equals 4/2. And so we get 13/2 here, 9 plus 4, equals, question mark, 3 minus 16 is just -13/2. But since we're looking at the absolute value, so we have 13/2 on the left equals, and because we're looking at the absolute value, the -13 becomes +13, and we get the correct answer. So both these answers are correct and relevant in this case. So this was a simple example just to show what we do when we have two absolute value terms in a linear equation. Now, we can have more complicated examples than this, but this really explains how to deal with an equation where we have two absolute value terms. If this video was helpful to you, please comment below and like, and I'll see you in the next video.